Part 3 of Chapter 2, the metric system. This is the international system of measurements that's used in literally every country of the world except America, Burma, and there was one more, I think it's Sierra Leone. But pretty much every other country has adopted the metric system because the metric system is a lot easier. It's base 10. Everything is in base 10. In the American system, there's a lot of conversions to memorize. There's 12 inches in a foot. There's 3 feet in a yard. I don't even know how many feet are in a mile. I never memorized it, but it's like 5,000 some. But again, everything seems to have its own number that needs to be memorized. Whereas in the metric system, everything is a multiple of 10. So once you learn the prefixes, it's pretty simple. There are 7 basic things you can measure in the universe. One of them is a length, and we measure them in meters. One of them is a mass. We measure it in kilograms. One of them is a temperature. We measure in Kelvin. Time in seconds. The amount of substance in moles. Electric current in amperes. And it's not on the PowerPoint, but luminous intensity. How bright something is measured in candelas. And we don't do that in this class, but that is the 7th one. So there's only 7 fundamental things that can be measured. Every other unit will be made up of these units. Like velocity, that is a length per time. How many meters per second are you moving? Acceleration, your change in velocity, meters per second per second. Force, that's a mass times acceleration. That's a kilogram times a meter per second per second. Work, force times a distance. Now you have a mass times an acceleration times a distance. So you have a kilograms times meters per second times meters. Every other unit in science is made up of these 7 basic units. Every other unit can be broken down to these 7 basic fundamental things that can be measured. And we have prefixes. There's a couple important ones missing. Giga is a billion of something. So if you have a flash drive, it's probably like 16 gigabytes. So giga is 1 billion of something. Capital G. And it is 1 billion. 1 times 10 to the 9. Or 1 with 9 zeros after it. It is 1,000 millions. And then above that is tera. And these days with computers, tera is actually used. You can go to Walmart and buy a 2 terabyte flat or portable hard drive to store all your movies and pictures on. So tera, T-E-R-A, capital T, means a trillion. 1 times 10 to the 12th. 1 times 10 to the 12th. Or 1 with 12 zeros after it. Mega, capital M, is 1 million of something. Kilo, 1,000 of something. And then we get to deci, 1/10 of something. Centi, 1/100th of something, like a centimeter is 1/100th of a meter. Milli, 1,000th of something. A millisecond is 1,000th of a second. A millimeter is 1,000th of a meter. A milliliter is 1,000th of a liter. Micro is 1 millionth of something. Notice the symbol's kind of weird. That's a Greek letter mu. It's the only letter that's not from the Latin alphabet, which is what English uses, and so that's why it looks unfamiliar to you. That is the Greek letter mu, and it is for micro, which is 1 millionth of something. And then nano is 1 billionth of something. And we can go even smaller. Pico, 1 trillionth of something. So pico, small p, and 1 times 10 to the minus 12. 1 trillionth of something. But now that you've memorized the 7 basic things you can measure and these prefixes, we can do every conversion in the metric system. And that's why it's so much easier than the American system, is that you don't have a lot of different numbers to memorize. Everything is base 10. Everything changes in a unit of 10. So the meter is a standard unit of length of the metric system. This is the distance that light travels in a vacuum in 1, 299,792,458 of a second. It was a big goal in science to find constants of the universe to define these things, because the problem with using physical objects is that physical objects change over time, and when that is your master calibrator, which all your measurements depend on, if it changes, then that messes everything up. And so over time, all of our standards have changed to constants of the universe. The kilogram was the last one, and that was done a year or two ago. They finally found a constant of the universe to measure a kilogram by, because before that we used this platinum iridium cylinder that was held in a vault in France, but they could tell that over time it was changing, and so that again, even with the most noble inert metals sealed under inert noble gases, there's still change. There's always change chemically over time, and therefore physical objects are not good constants. 1 meter is 100 centimeters. A kilometer is 1,000 meters. If you drive up to Canada, you'll notice the speed limit changes to 90 kilometers per hour. It's important to note that that's kilometers, because that really is like 55 miles per hour and not 90 miles per hour. An important conversion unit is right here. This allows us to convert between the American system and the metric system. 1 inch is 2.54 centimeters exactly. That is a defined number. It is infinitely significant. Dimensional analysis is the art of converting one unit to another unit. And basically, you're multiplying things by 1, honestly, because here 1 kilometer is the exact same thing as 1,000 meters, just a different way to say it, different units. But the value is the same. 1 kilometer is the exact same length as 1,000 meters. And because of that, 1 kilometer divided by 1,000 meters is just a really fancy way to say 1. And when we do dimensional analysis, you'll notice the old units disappear. 2 meters times 1 kilometer divided by 1,000 meters, and we get 0.002 kilometers. What happened to the meters? Well, they canceled out. Because let's think about some basic math. What's 5 divided by 5? It's 1. 7 divided by 7? It's 1. 10 divided by 10? It's 1. 50 divided by 50? It's 1. Zebra divided by zebra, still 1. Anything divided by itself is 1, and that applies to units. So meter divided by meter is 1. They cancel out, and that is why it disappears, and that's important. When you're doing these problems or practicing, always write down the units. The fastest way to get these problems wrong is to just write the numbers, because you immediately forget what the units were supposed to be, and then you lose context of what the problem is. So like a measurement requires both a number and a unit, and it's good practice to always write both of them. The unit you're converting into, we wanted to convert into kilometers, so kilometers goes on top. The old unit that you started with and are getting rid of, that goes on bottom. And if you flip it, you will get a nonsensical unit. If we accidentally flip this and had 2 meters times 1,000 meters divided by 1 kilometer, we would get 2,000 meters squared per kilometer, which doesn't mean anything. And when you get a nonsensical unit, you know you flipped something. So convert 215 centimeters to meters. Well, the conversion factor I need is, in 1 meter there are 100 centimeters. And now, centimeters cancels out, giving me 2.15 meters. 125 meters into kilometers. My conversion, kilo is 1,000. In 1 kilometer there are 1,000 meters. Meter divided by meter is 1. They cancel out, giving me 0.125 kilometers. How many micrometers are in 0.03 meters? Well, micro was 1/1,000,000th of something. There are 1,000,000 micrometers in a meter. And meter divided by meter cancels out, giving me 30,000 micrometers. It's always easier to do multiple easy problems as opposed to one hard problem. So how many seconds are in a day? I have no idea whatsoever. But I know that in one day there's 24 hours. And I know that in 1 hour there's 60 minutes. And I know that in 1 minute there's 60 seconds. And therefore, I can set up 3 easy problems that I know how to do and easily get the answer. We convert days into hours. There's 24 hours in a day. Day divided by day cancels out. There's 60 minutes in an hour. Hour divided by hour cancels out. There's 60 seconds in a minute. Minute divided by minute cancels out to get 8.64 times 10 to the 4th seconds. So while I didn't know how to directly go from days to seconds, I did know an easier way. And it's always easier to do multiple easy problems than one hard problem. How many feet are in 250 centimeters? Well, I have no idea. But I know that 1 inch is 2.54 centimeters. And I know that 1 foot is 12 inches. And so I can work it through and get 8.20 feet. How many meters are in 5 yards? Meters and yards are relatively similar in both the metric system and the American system, meaning that that's a useful measurement. That's a useful amount of length. I have no idea how many meters are in 5 yards, but I know that there are 3 feet in 1 yard. And I know that there are 12 inches in 1 foot. And I learned in this chapter that there are 2.54 centimeters in an inch. And so I can convert from yards to feet to inches to centimeters, and then because of my metric prefixes, there's 1 meter is the same as 100 centimeters. I can convert centimeters to meters and get an answer. And 5 yards is 4.57 meters. And so meters are just like 10% bigger than a yard. When we go into the 3 dimensions, what messes students up is they forget to make the conversion factor into 3 dimensions too. So here I have a box that's 2.2 times 4 times 6 inches. So let's say I multiply those out. I get 52.8 cubic inches. But when I convert, what's a cubic inch? Well, a cubic inch would be 1 inch tall. So let's draw this out. It'd be 1 inch tall, 1 inch wide, and 1 inch deep. That would be a cubic inch. So 1 inch, 1 inch, and 1 inch. But another way to say that, because we remember 1 inch was 2.54 centimeters. So another way I could say that, instead of saying 1 inch by 1 inch by 1 inch, I could say 2.54 centimeters by 2.54 centimeters by 2.54 centimeters. So really, 1 cubic inch is 1 inch by 1 inch by 1 inch, which is the same as 2.54 centimeters times 2.54 centimeters by 2.54 centimeters. And so the conversion factor has to be cubed, actually. And that is the hardest part of those. For example, 1 cubic meter. How many cubic centimeters is that? Well, a cubic meter is a meter by a meter by a meter. But another way to say that is 100 centimeters times 100 centimeters times 100 centimeters. So a cubic meter is actually 1,000,000 cubic centimeters. So again, when you go into the 3rd dimension, you have to cube the conversion factors. If you're in 2 dimensions, you have to square the conversions factors. Like a square meter is a meter by a meter, which is 100 centimeters by 100 centimeters, which is 10,000 square centimeters. And that is the end of part 3 of chapter 2.